Alright, what's up guys? We're doing binary tree, zigzag, level, or traversal. Top interview questions, medium set, binary tree, question number 2. So given the root of the binary tree, return the zigzag, level, or traversal with nodes values. So for the first level, you want to go left to right, then right to left, then left to right. Alright, and over here they just have some edge cases. So let's look at an example that I set up for you guys. So for this question, let me just hide all of that. You want to go left to right, A, then right to left, C, B, then left to right again, D, F, G, and I, H. And that's exactly what the zigzag level order traversal is. So you might be thinking, what's a level order traversal? Because they say zigzag level order traversal. Level order traversal is you always just go left to right. So over here you go A, B, C, D, F, G, H, I. You might be wondering, alright, how do I get a zigzag from a level order traversal? And it's pretty obvious. You just reverse the list. I go right to left, so they go left to right, right? Easy. So how do I get a level order traversal? That's the next question that comes up. So the way I see it, there's 3 steps to level order traversal. So you got to get the nodes that are stored on a level and a data structure. Let me just delete the zigzag. So you get A, right? And then you want to add its children to the data structure, or you want to add A to a list first for that row. So a list just for that row. Then you want to add children to the data structure, and then repeat the process just like that, rinse and repeat, right? But you might be wondering, what's the ideal data structure to use? So for one value, it really doesn't matter. You know, you can use a stack or queue. It's only one value. It doesn't affect the flow. But when you have 2 values, it's when it really matters. So you have A and you add B and C to some data structure. I'll let you know. You guys will figure it out with me. So for B, you add it to the list and you add in D and E, and then you want to access C. So let's just give a little example here. We have a queue and we have some lists. So initially our queue has A, right? And you want to pop A out as, oh, I give it away, it's a queue. But basically, I'll show you how this works. So you add in A to the list, then you have B and C in your queue. You want to add in B, add its children to a queue, which are D and E, and then you want to pop out C and add its children to a queue, which are F and G. But the reason we use the queue is because look how we're able to access B and C first, because they're first in, first out. That's obviously a queue. And you might be wondering, Bob, how do I know when to stop? Like, why wouldn't I just stop at BC? What if I just kept on going? And the secret of that is you look at how many values, how many nodes are in the queue before you start popping out and adding in new values. That way, you know how many nodes you have to look at for that level. So in this level is just 2. So this level, you'd only look at 4 values, but the queue could get bigger. Like, pop out D, add its children, which are just H, and then you pop out E, add in its children, it doesn't have any. Then F, pop in its children, which is I, and then pop out G, and add in its children, which doesn't have any. And you stop here because you knew from before there's only 4 values in this level, and then you just make another while loop. In your while loop, you create a new list for that row. You just add in, rinse and repeat, just add in all the values to the list, add the new values to the queue. And with that, we have the solution. So let me quickly talk about space and time complexity. Space complexity, worst case, we're just storing one value. It's the node in a queue, that's O of n. Time complexity, on the other hand, the time complexity is 1. You gotta think about the traversal and reversing the list. So the traversal is O of n, right? You traverse through the entire n nodes, but reversing, it may increase that to O of n log n or O of n squared. I'm going to show you guys a way to keep it O of n. Basically the way you can add to a list is you can add to the front of the list or you can add to the back of the list. So if you continually add to the back of the list, you're basically adding them in reverse order. So let me show you real quick. So D, E, F, G, right? Say you wanted to reverse this and you want to add it to a reverse list. So you always add it to the front. That's the secret. So first you add in D, then you add in E, then you add in F, and then you add in G. And as you're always adding them to the front, the last value is in the front, and the first value is in the last. And that's basically the idea on how to keep this solution on space, on time to really impress your interviewer. So now let's start coding up the solution. First thing we need, return array. We need a queue to store our tree nodes. And first check we want to do is we want to check if the root value that we're looking at is null, because then you just return the empty list. And we need a starting node to go through all the children in the tree, right? Because we're just adding into a queue. But if there's no starting node, if it's null, then we can't really do anything. So we just return an empty list. Great. Otherwise, you want to add it to the queue. So queue.add roots. And you want to do a while loop while the queue is not empty. First things first, add a list of integer for that row. We'll call that cur row. Alright, now you want to look at the length of the queue before you add or push anything out of it. So int row length is equal to queue.size. Alright, cool. And let's make a value to store the current node that we're looking at. Perfect. So you want to make a for loop only through the values in that row, which so for it I is equal to 0, I is less than row length, plus, and new keyboard. Alright. What you want to do is first thing, cur is equal to queue.pull. That's how you get the front of the queue. First in, first out. Then you want to add that to your cur row. But we gotta, well, we'll think about zigzag in a second. Then you want to add the left and right children if they exist. So if cur.left is not equal to null, then queue.add cur.left. And do the same thing for the right. Alright, that's cool. And what we want to do is we want to add that current row into our list of lists. And at the end, you want to return our return array. That looks good. And this is right now, it's just a level or traversal. How we're going to make it zigzag level or traversal is we're going to add a boolean to check if we should reverse the row. And initially it's equal to false, right? First one you don't reverse, second one you do. And every time you want to flip the value. So reverse row is equal to not reverse row. Alright, and got a colon there. And the way you do it is, I showed you before. So if you reverse row, you want to add it to the front. So for list in Java, they have this index and value. So you can define the index to be 0, and that way you can add to the front of the list. Otherwise, you can just add to the back, so not indicating an index, just automatically adds it to the back of the list. Alright, that looks good. Let's try running it. Okay, dang. You guys are ruthless with syntax. Honestly, that's a reason I don't like Java. I think I might just switch. Oh yeah, I called it cur everywhere else except for the declaration. So I'm going to be switching to C++ for my later videos. I'm still going to have Java solutions up on the GitHub page. It's pretty much going to be the same. So solution was accepted, but I really want to try learning C++, and I think it would be a good opportunity. Don't worry though, all the solutions will still be posted in Java on the GitHub. And the explanations are pretty much universal. So thank you guys so much for watching. Leave a like, comment, subscribe. Give me some suggestions on how I can make these videos better. I'll see you guys in the next one. And that's about it. Code's in the GitHub description, so check that out. Peace out.